You know, the universe has one law that is truly unbreakable. It's not a guideline, it's not a suggestion, it's a hard, fundamental limit that's literally written into the fabric of reality itself. And today, we're going to figure out why.
I mean, why can't we just keep pushing something, keep accelerating it forever? Our entire lives, our intuition tells us that speeds just add up. If you're on a train and you throw a ball, the speeds combine. So why does the universe just slam on the brakes at exactly 299,792,458 meters per second? That's the core mystery we are unpacking.
To find the answer, we have to go back in time, to a moment when one of the most trusted laws of physics just started to break.
So on the left, you've got the world as Isaac Newton saw it, and frankly, how we all experience it every day. It's simple, it's additive, it makes sense. You're on a train going 100 kilometers an hour, you throw a ball forward at 20, someone on the ground sees it moving at 120. Easy. But on the right, well, that's where the universe gets weird. If you're on a spaceship rocketing along at half the speed of light and you turn on a flashlight, you and someone watching from a planet both see that light moving at exactly c, the speed of light. That should be impossible. The first clue that something was really wrong came from the work of James Clerk Maxwell. He was unifying electricity and magnetism, and boom, his equations spit out a very specific number for the speed of light. But there was a huge problem. They didn't say what that speed was measured relative to. It was just constant. For physicists at the time, this was a major crisis.
So, two physicists, Albert Michelson and Edward Morley, they set up this brilliant experiment. They were trying to measure the Earth's speed through something they called the ether, this invisible stuff they thought light had to travel through. But they found nothing, a null result. It didn't matter which way the Earth was moving, the speed of light was always the same. The universe was basically screaming at us that this speed was an absolute constant for everyone. And then Albert Einstein comes along. He didn't try to fight this bizarre result. He made it the foundation of his entire theory. His logic was just profound. Think about it. If speed equals distance divided by time, and you accept that the speed part is always locked at c, then something else has to be flexible. The other two variables, distance and time, they couldn't be absolute anymore. They had to stretch and shrink depending on your motion, just to make the math work. Space-time itself had to be bendy.
Okay, so if the speed is constant, why can't we just, push through it? Well, the first and most direct answer is a brute force barrier made of pure energy.
Stephen Hawking just summed it up perfectly. As you get closer and closer to the speed of light, things get really strange. The energy you're pouring in doesn't just make you go faster. It starts doing something else entirely.
And the key is, of course, the most famous equation in the world, E equals mc squared. It tells us that energy and mass are basically two sides of the same coin. So as you pump kinetic energy into an object to speed it up, that energy actually adds to the object's inertia. Its resistance to being pushed. It kind of gets heavier. Now this is the math that actually governs that whole process. It's called the Lorentz factor, or gamma. Now don't worry, just look at the bottom of that fraction. As your velocity, v, gets closer and closer to c, that whole term approaches 1. You get 1 minus something almost 1, which is a number incredibly close to 0. And what happens when you divide by a number that's almost 0? The result just skyrockets towards infinity.
And here's what that looks like with actual numbers. At 10% of light speed, the effect is tiny. You'd barely notice. But look at that jump from 90% to 99%. Your inertia more than triples. By the time you hit 99.9%, you're over 22 times harder to push than when you started. To get to 100%? Well, you'd need an infinite amount of energy, because the object's resistance would become infinite.
And this isn't just a theory. This number right here, this is the actual speed of protons at the Large Hadron Collider at CERN. That is unbelievably close to the ultimate limit.
And to get them moving that fast, the LHC uses about as much power as the entire city of Geneva. But here's the kicker. If they were to double the energy they put in, the protons wouldn't get twice as fast. They just get another 9 or 2 after the decimal point, and their inertia would climb even higher. The LHC is pretty much the world's most powerful proof that we are hitting a real physical wall.
But that infinite energy wall? It's really just a symptom of a much, much deeper truth. The real reason for the speed limit isn't about energy at all. It's built right into the very geometry of our universe.
Okay, this is a mind-bending idea, but it's a really powerful way to think about it. Ready? Everything in the universe, you, me, this planet, is constantly moving through four-dimensional space-time at one single speed, the speed of light.
Right now, as you're sitting still, you are using 100% of your speed budget to travel through the dimension of time. But if you start moving through space, you have to borrow some of that speed from your time dimension. And what does that mean? Your clock starts ticking slower relative to everyone you left behind. And if you could actually reach the speed of light, well, you'd be using 100% of your speed budget to move through space, which leaves 0 for time. Your personal time would literally stop. For a photon that travels from a star a billion light years away, its entire journey happens in a single instant from its own perspective. Wild, right?
So all of this builds to what is probably the most profound reason of all. The speed limit isn't just some rule of physics, it is the ultimate protector of logic and reality itself.
Every single thing that happens, every event in the universe, creates what's called a light cone. Just think of it like a bubble of cause and effect that expands outwards at the speed of light. Anything you do can only affect things that are inside your future light cone. Anything outside it is, for the moment, totally beyond your reach.
So, what if you could travel faster than light? You could send a signal that outruns its own light cone. And the math of relativity is crystal clear on this. For any faster-than-light signal, there is always some frame of reference where the effect happens before the cause. A message arrives before you send it. You could create paradoxes that would just shatter the logical consistency of reality. And this leads to this fantastic saying in physics. You can have a universe that follows the laws of relativity and has a consistent chain of cause and effect. Or you can have faster-than-light travel. You just can't have all three. The universe has already made its choice.
So this isn't just some abstract theory. These cosmic rules have very real consequences for our technology and, well, for our future.
So why does any of this matter to you? Well, your phone's GPS for starters. The satellites orbiting Earth are moving really fast, and they're in weaker gravity, which means their clocks actually run faster than ours, by about 38 microseconds every single day. That sounds tiny, right? But if engineers didn't constantly correct for that relativistic effect, your GPS location would drift by 11 kilometers every day, making it totally useless. Your phone is literally a pocket-sized proof that space-time is flexible.
But the speed limit also has a much more sobering consequence. It puts humanity in a kind of cosmic quarantine. Even if you could travel at, say, 99.99% the speed of light, a trip to our neighboring Andromeda galaxy would still take 2.5 million years as measured back here on Earth. Now for you, because of time dilation, it might only feel like a few decades, but when you arrived, everyone and everything you ever knew would be long, long gone. It is a one-way ticket into the future.
Which brings us to our final thought. Is this ultimate speed limit a frustrating prison confining us to our tiny little corner of the cosmos? Or is it a necessary law? Is it the ultimate guardian that protects reality from paradox and makes sure the universe has a coherent story where cause always comes before effect? Maybe the very thing that limits us is the same thing that makes our existence possible in the first place.